Sindhu Rekha, Department of ECE, working as an assistant professor in Mlritm Engineering College. Today I am going to discuss about the subject is embedded system design. Today we are going to cover these many topics. Those are definition of embedded system, and next one is differences between general purpose system and embedded system, and then history of embedded system, and then coming to the classifications of embedded system, and last one is memories of embedded system. Okay, coming to the definition of embedded system, before going to the embedded system we should know the definition of system. So here system is nothing but set of instructions are worked together to perform a task is nothing but system. Now coming to the embedded system, all many components are worked together to perform a particular task or specific task is nothing but embedded system. So here an embedded system is an electronic electromechanical system designed to perform a specific task. So every embedded system contains these three components. It may be electronic parts and electromechanical parts. That's why it is a electronic or electromechanical system. So that's why it is perform a specific function, and it is a combination of both hardware and firmware. For firmware is nothing but software. So simply you can call embedded system is nothing but a combination of hardware and software, and it is a electronic or electromechanical system which is used to design to perform a particular task is nothing but embedded system. And then every embedded system is unique and the hardware as well as firmware. That means every embedded system means it is a depends on application, and it contains unique hardware and software, and it is a highly specialized to the application domain. Okay, and then coming to the examples of embedded system, we can use in household appliances like TV, AC, fridge, and telecommunications, mobile phones, medical equipment like ECG and EEG scans, and industrial control and consumer products. And these are the examples of the embedded system. And then coming to the differences. So differences between general purpose system and embedded system, and these are the criteria we can compare now. Coming to the general purpose computing system, a system which is a combination of generic hardware and general purpose operating system for executing the different types of application. So in our general PC, to perform many applications like audio browsing, video, chatting, like that. So for that purpose we can use generic hardware and general purpose OS. But coming to the embedded system, it is a combination of special purpose hardware and an embedded OS for executing a specific set of applications. So here we can use the embedded related operating system. And then second one is operating system. In general purpose system, we can use general purpose OS only. But coming to the embedded system, that OS may or may not contain. It may be there or may not be there. Okay, depends on application. We can having the OS in the embedded system. But in general purpose system, for any applications to run, general purpose OS is compulsory. Okay, and then alterations. Here in general purpose system, applications are alterable or programmable by the user. In our PC, we can install many applications as well as we can delete the application. That is in our hands. So that is the applications are alterable or programmable. But coming to the embedded system, the firmware means the software of the embedded system is pre-programmed and it is a non-alterable by the end user. So in this, the software is pre-programmed and not changeable by the end user. So that is the third point. And next, key factor means performance is the key deciding factor in the selection of the embedded system. Faster is better. Okay, while purchasing the general purpose system, we can measure the performance in terms of faster and better or nothing but speed. So that is the key deciding factor. And then embedded system applications are specific requirements like performance, power requirements, memory usage are key deciding factors. So depends on applications, the key factors are changeable. Those are in the performance point or power requirements and memory usage. So these are the key deciding factor, depends on application orientation. Okay, next, power consumption. So in general purpose system, power is more. Why? Because many applications are run at a time. So that's why power consumption is more. And in this, power consumption is less. Why? Because it performs a single task. Okay, and then response time. Response time is not critical in general purpose system and critical for some application, not for all applications. So these some applications are applicable in hard real time system. We have two types of systems, soft real time and hard real time. At hard real time point of view, this time response is critical in embedded system, but in general purpose, time response is not critical. And last one is execution. So need not to be deterministic in general purpose system and deterministic for certain types of embedded system like hard real time system. So it depends on our input, we can get the output compulsory at the time of execution. These are the differences between general purpose computing system and embedded system. And then coming to the history of the embedded system. In olden days, embedded systems are built using vacuum tubes and transistor technology. Embedded algorithms were developed in low-level language. So here low-level language means mission level language in terms of zeros and one. So in previous days, embedded systems are developed using vacuum tubes and transistor technology. For this, algorithms developed languages, assembly level language or low level language. Okay, and then first recognized modern embedded system is AGC. So AGC is the first recognized modern embedded system, and this one is developed by the Charles Stark Darper at the MIT Instrumentation Laboratory in the year of 1960. So here AGC means Apollo Guidance Computer, and it contains two modules. One is command module and second one is lunar excursion module. So in the year of 1960, AGC developed by the Stark Darper at the MIT University or nothing but MIT laboratory. It contains two modules. Those are command module and lunar excursion module. So this AGC contains RAM size is 256 words and 1K words and 2K words. The RAM size is 256 to 2K words. And then ROM size is 4K words to 10K words and 36K words, means 4K to 36K word size. And then clock frequency is 1.024 megahertz frequency. And it contains three input RTL NOR gates are used. Here RTL means register transfer level, NOR gates are used. And the final one is user interface is DSKY. Means DS means display and KY means keyboard. So these are the AGC features. So this is the diagram, shows the display. Means these are the keyboards symbols and this is the display of DSKY. And then in 1965, Autonetics developed the D17B. So in the year of 1965, D17B comes into the picture and it was used in the computer in the missile guidance system. and it is widely recognized as the first mass produced embedded system. After that, in 1968, the first embedded system vehicle was released. That was Volkswagen 1600. So in this, to manage its electric fuel injection system in the year of 1968. And then in 1971, Texas Instruments developed the first microcontroller in the year of 1971. And then in 1987, the first embedded operating system VxWorks was released by the Wind River. So these two are the softwares. And then with the advent of semiconductor technology, nanotechnology and IT revolution, miniature embedded systems are came into the picture. After semiconductor technology, so 1G, 2G, 3G, 4G. Now we are in 5G technology. So this is about history of embedded system. And then classifications of embedded system. It is classified into different criteria. Those are based on generation and complexity and performance requirements, based on deterministic behavior, based on triggering. So again, based on generation, it can be divided into four parts: 3G, 4G. So I'll show in the next slide. So classification based on generation, it can be divided into 4 generations. Those are: first generation means 1G, and second generation means 2G, and third generation means 3G, and fourth generation means 4G. So these are the different generations. Coming to the first generation, so in this generation, built around 8-bit microprocessor and 4-bit microcontrollers. So in first generation, systems was developed built around 8-bit microprocessor and 4-bit microcontrollers. And in this used simple hardware circuits with firmware developed in assembly code. So in this used hardware and software is simple. Okay, and then examples of first generations are digital telephone keypads and stepper motor control units. This is the picture of digital telephone keypads. And then coming to the second generation, it built around 16-bit microprocessor and 8-bit microcontroller. Now it is processor and controllers count are double compared to the 1G. So in 1G, 8-bit microprocessor are used, in 4-bit microcontrollers are used. Now values are doubled in 2G compared to the 1G generation. So the instruction set for the second generation processor controller were more complex and powerful than the first generation processor controller. So in the first generation, hardware and software is very simple, but here in second generation it is very complex compared to the 1G. Okay, and then examples are data acquisition system and SCADA system. This is the picture of data acquisition. So here we can encoding decoding processor will be done. Here SCADA means supervisory control and data acquisition system. So this is about second generation. And then coming to the third generation, in this 32-bit microprocessor and 16-bit microcontrollers, and also used digital signal processor and application specific integrated circuits also. Now here again double the count of the processor and controllers. So in this, the instruction set of processors become more complex and powerful. The concept of pipelining also evolved. So this means compared to the 2G, in 3G, hardware and software is more complex, and also pipelining concept is also evolved. Here pipelining is nothing but one of the output is given to the input for another device. So that concept also introduced in 3G. So examples of third generation is robotics. This is the picture of robotic. And then coming to the fourth generation. So in fourth generation, the count of the microprocessor is 64-bit and controller is 32-bit. Okay, in the concept of system on chip is introduced and multi-core processor also evolved in the fourth generation. So these are the pictures of the multi-core process, and it is high complex and very powerful. Means software and hardware complexion is very difficult compared to the previous generations. Means it is very hard and very powerful compared to the previous ones. And examples of fourth generations are smartphone devices and mobile internet devices. And this is the different generation pictures in 0G, 1G, 2G, 3G and 4G and 5G. And this is the every generation. So microprocessor and microcontrollers are doubled by using the semiconductor technology. And then classification based on complexity and performance. This is the second classification. So this can be classified into three types. Those are small scale embedded system and medium scale embedded system and large scale embedded system. Coming to the small scale embedded system, it is very simple to design. Simple to design means hardware and software is very simple to design, and performance is not time critical. Here time not critical means response time is not critical. These are built around low performance and low cost, and it is 8 or 16-bit, 8-bit microprocessor and 16-bit microcontrollers are used in the small scale embedded system, and then may or may not contain an operating system. So already we discussed all embedded systems are need not to have the operating system. It may contain or may not be contained. So in small scale embedded system, may or may not contain the OS. Okay, examples are electronic toys and smart cards. And this is the example diagram of a smart card. And then coming to the medium scale embedded system, these are slightly complex in hardware and software compared to the small scale embedded system, and it gives the medium performance and uses 16-bit microprocessor and 32-bit microcontroller, and also used DSPs and ASICs, and it has the OS, that is real-time operating system. In medium scale embedded system, OS is there. That OS should be real-time operating system. In previous small scale embedded system, it may or may not contain the OS, but here OS should be is there. That OS is real-time operating system. So the main programming tools used for these systems include C, C++, Java and Visual C++ and real-time operating system. These are the tools in medium scale embedded system. And examples of the medium scale embedded systems are ATMs and automotive navigation system, means GPS tracking, home appliances and medical devices. And coming to the large scale embedded system, highly complex and hardware and software compared to the previous embedded systems, and it contains 32-bit processor and 64-bit controller, and also multi-core processor and PLDs, and it gives the high performance real-time operating system. Examples of the large scale embedded systems are aerospace, industrial automation, advanced robotics, wireless communication system. This picture shows the aerospace in large scale embedded system. And third one is based on deterministic behavior. It can be divided into two types. Those are soft real-time systems and hard real-time system. Coming to the soft real-time system, in this type of embedded system, deadline is not strictly followed. Missing deadline for tasks are acceptable for soft real-time system. So best example is ATM mission. Response time is not mandatory and there is no deadline in the soft real system. And this is the simple quotation. A late answer is an acceptable answer in, if you get the late answer, that is also acceptable in the soft real-time system. But coming to the hard real-time system, a late answer is always wrong answer. The best example is airbag control system. A hard real-time system must meet the timing deadlines without any delay. Missing the deadline would cause serious failure to the system or user. Okay, this is about based on deterministic behavior. And fourth one is based on triggering. Again, classified into two types: time trigger and event trigger. So in time trigger, if a system is activated or triggered based on the predefined task, so before we can fix the time, based on that we can trigger the device. But coming to the event trigger, if the system is triggered based on some activity like changes in the temperature or change in pressure, so depends on climate or weather, temperature, pressure, like that, the system will be triggered. That is event trigger. And next, coming to the memories in embedded system. So memory plays a key role. For what purpose we can use memory means to store the data or information permanently or temporarily. Okay, memory is an important of an embedded system. The memory used in embedded system can be either program storage memory is nothing but ROM, read-only memory, or data memory is nothing but RAM, random access memory. This can be divided into two types of memories. One is on-chip memory or nothing but primary memory, and off-chip memory is nothing but secondary memory. These are the different types of memories we have. So memory can be divided into two types. One is primary memory and secondary memory. So these are the external devices like pen drive, CDs, DVD players, like that. This is also storage, permanent storage purpose. And in primary memory, it directly access the data from the CPU, RAM and ROM. Again, RAM can be divided into two types: static random access memory and DRAM means dynamic access memory. And come to the ROM. This is programmable read-only memory, and this one is erasable programmable read-only memory, and this is electrically erasable programmable ROM, and this is masked ROM. So in this, PROM means programmable read-only memory. So in this memory we can programmable one time. Only single time you can program the data memory. Okay, but coming to the EPROM, here we can erase the data and program the data in one time by using the UV light. And then coming to the electrically erasable programmable read-only memory. In this we can do thousands of times we can erase the data and reprogram the data. But in MRAM, we can't change the data. It is fixed while time of manufacturing. So these all about memories in embedded system. Thank you.